Hi, welcome to Unit 6, Day 6, One-Step Mole Conversions. This is Part 1 where we're focusing on conversion factors. So before we begin, let's do a recap of the things that we have learned so far in this unit. On the first day, we learned the importance of moles and what they are. So we learned that one mole is sort of like a dozen, and one mole is equal to 602 hexillion, or 6.02 times 10 to the 23 things. We also learned that mole is a central unit of measurements for amounts, and that's because all other amounts can be converted to and from moles. And moles are also used to describe a balanced chemical equation, and in fact the coefficients in the balanced chemical equation are molar coefficients. The next couple of days we learned how to calculate molar mass and how to use the molar mass as a conversion factor to convert to and from mass to moles in a one-step problem. And the math method that we use for this is dimensional analysis. So we did those sort of one-step conversions. An example of that would be a problem like, how much does 1.2 moles of NH3 weigh? So in this problem we're given the moles and we're trying to convert it to mass. And since we're going from moles to mass, we use the 1 mole equals molar mass as our conversion factor. And then we solve the problem, again, using dimensional analysis according to this setup here. And then our math looks something like this. So we can cancel out the units that we're given, leaving us with, after we do multiply, leaving us with 20.4 grams as our answer. So 1.2 moles of NH3 would weigh 20.4 grams. Now, the last few days, what we did is we sort of took a deeper dive into molar mass. So day 4 to 5, we took a deeper dive into molar mass, and we used mass and molar mass to calculate percent composition or mass percent. And then we did a lab where we used the percent composition to identify an unknown hydrate. Now today what we're going to do is we're going to go back to conversions, more one-step conversions. And this time we are going to look at converting between number of particles and moles. And for that we use 6.02 times 10 to the 23 or Avogadro's number as a conversion factor. And we're also going to look at converting between volume of a gas at STP, and for that we used 22.4 liter as the conversion factor. And of course, we'll continue to use dimensional analysis as our method to solve. So this is sort of bringing us back to what we did the days 2 through 3. Now, there are two main steps to solving these conversion problems. And when I say conversion problems, there are problems that sound something like this. So how many moles of H2O are in 5 grams of H2O? What's the volume in milliliters of 4.13 mole sample of helium gas? And how many H2O molecules are there in 1.93 moles of H2O? So for these types of problems, the two main steps is first to choose the correct conversion factor. And these are the 3 conversion factors that we have to choose from. The second step is to use dimensional analysis to solve the problem. In this video, we're going to focus really on step 1 and understanding the conversion factors, and then later you will see examples and complete practice problems using both steps. All right, so the key to solving any of these problems is picking the right conversion factor. And as I said, there are 3 conversion factors that you need to know. So 1 mole equals molar mass, 1 mole equals 6.02 times 10 to the 23, and 1 mole is equal to 22.4 liters for the volume of a gas at STP. Now, in order to be able to pick the right conversion factor, it's important that you understand these conversion factors. And so one strategy for understanding them is to do a sort of a compare and contrast. So I want you to take a look at all 3 conversion factors. You can either look here and or on the mole map, and I want you to identify similarities and differences. So why don't you pause the video now, and then after that we'll come back together and look at those similarities and differences. All right, so let's take a look at some of the similarities and differences that I noticed. Now, your list may be a little different from mine. Maybe you have more or less things, but here are some of the key things that I noticed. Let's start off with the similarities. I noticed that of all three conversion factors start with 1 mole is equal to something else. So they all have 1 mole equals in the conversion factors. I also noticed that in the mole map, the conversion factors are all written sort of along the arrows there. So let's take a look at these similarities and understand them, because by understanding the similarities, we'll understand more about the purpose and the usefulness of the conversion factor. Okay, so the conversion factors are used to convert from moles to some other amount. And remember, we looked on day, I believe it was day 2, if you have a given, the conversion factor is sort of like a machine that converts that given into your find. So why do they all have 1 mole? Well, they all have 1 mole because if the conversion factor is converting from the given to the find, the conversion factors must show the relationship between the mole and the other amount you're trying to convert to and from. So they all have to be set equal to 1 mole, because if you know, like for example, if you know how much 1 mole of something weighs, then if you have a different number of moles, or if you have a particular weight, you can convert to and from the moles and mass. The other thing about the similarities is that the conversion factors are written along these arrows in the mole map. So why is that? Well, they're written along the arrows in the mole map because they essentially are connecting the moles to different amounts. And in order to go to or from mole in that different amount, you have to sort of go through the conversion factor. So for example, to go from mass to moles or moles to mass, you have to go through 1 mole is equal to the molar mass. To go from moles to volume of a gas or volume of a gas to moles, you have to go through 1 mole is equal to 22.4 liters. And to go from moles to number of particles, whether that's atoms or molecules, you have to go through 1 mole is equal to 6.02 times 10 to the 23. All right, so now that we understand sort of the purpose of the conversion factors as explained by their similarities, now let's take a look at their differences. So in terms of differences, they all sort of end in something different. They all start with 1 mole is equal to something, but they all end in something different. Some in molar mass, one ends in 6.02 times 10 to the 23, another ends in 22.4 liters. So we're going to take a look at these differences to help us understand, to help us know how to pick the right conversion factor. And we're going to start by doing that with a problem. So in this problem, the CFU, you're going to be given 3 conversion factor or 3 sets of conversion factor problems. And you're going to try and match the problem to the right conversion factor to solve that problem. So let's reveal the 3 problems. This is a mass to moles problem, a volume of gas to moles, and a number of particles to mole. And you're going to match these 3 problems to the conversion factors. All right, go ahead and pause the video now. When you press play again, the answer will be revealed. All right, so let's take a look at the answer, starting with the mass to moles problem. If you want to convert to or from mass to moles, you have to use 1 mole is equal to the molar mass. If you want to convert from volume of gas to moles, you have to use 1 mole is equal to 22.4 liters. And from number of particles to mole, you have to use 1 mole is equal to 6.02 times 10 to the 23. So let's go through each one of these in turn so we can get a better sense of how we would know that we need to do that. Starting with the mass to mole conversion. Now, if you're given or asked to find the mass, you're going to use the molar mass conversion factor. And keywords in these sort of example problems that you'll see are words like mass, weight, or weighs. So, for example, here, the second problem says how much does 1.38 moles of H2O weigh? That's a keyword that we're dealing with mass here. And in fact, in this problem, we were trying to find mass. You also would look for units in these problems like grams, kilograms, or milligrams. Those are all units of mass. So that's another key that you're trying to go from mass to moles or moles to mass. And remember that for these problems, you must convert your units to grams. So if you're given milligrams, for example, you'd have to convert it to grams first. But for any problem where you see sort of any of these keywords like weighs or the units in grams, kilograms, and milligrams, then you know that you're going to use this conversion factor. 1 mole is equal to the molar mass. And you notice that in the conversion factor, the word mass is there. So that would make sense that this is the conversion factor used to go from mass to mole. The next conversion factor we're going to look at is volume of a gas. But before we do, let's just review what we mean by volume of gas. So first of all, volume measures the space occupied by matter. So you have an example here of different volume gas tanks, and you see they're different sizes. And for gases, especially particularly if they're ideal gas, they have one particular property that's important. All gases have the same volume as long as the moles, temperature, and pressure of the gas are the same. And at STP, standard temperature and pressure, which is 0 degrees Celsius and 1 atmosphere, 1 mole of gas will have a volume of 22.4 liters, which is about 6 gallons. For example, if you have 1 mole of helium gas at STP, the volume of the helium gas will be 22.4 liters. And if you have 1 mole of oxygen gas at STP, it will have a volume of 22.4 liters as well. So when we're converting from volume of a gas at STP to moles or vice versa, we use 1 mole is equal to 22.4 liters as our conversion factor. And some key things that you want to look for in problems like this are, of course, words like the volume. Also, you want to look for units like liters, milliliters, centimeters cube, or meters cube. Okay. And of course, if you're given your volume of a unit that's other than liters, then you have to convert it to liters. And if you're asked to find a unit other than liters, volume unit other than liters, you'll have to convert it to that unit as well, just to note that. But anyway, so any problem where you're dealing with volume of a gas, then you're going to be using the 1 mole is equal to 22.4 liters. The last example is when you're dealing with number of particles. So when I say number of particles, you're sort of counting the number of atoms or number of molecules. And in these types of problems, you are looking for certain keywords like how many atoms or how many molecules. So in that case, you're asked to count those number of things. You'll also see things like the power. The values are often written in power of tens, okay, like as in here. And your units, in this case, you want to make sure that you are counting, you want to make sure that you understand that you're actually counting atoms and molecules in these sort of problems. Okay. So what are the next steps? So what we're going to do now is you're going to complete the one-step mole conversion worksheet. And this is called one step because there's only one conversion that you're doing. You're either converting from mass to moles, for example, or from moles to volume or something. There's just one conversion that you're doing in each case. But this worksheet is divided into 2 parts. In the part 1, you're going to practice steps 1 and 2 separately. In part 2, you're going to do them all together. And then after each part, you're going to take an exit ticket. So you're going to have 2 days to sort of complete this because I'm dividing it out. And also to give you a chance to catch up on work. And I know some of you have AP exams this week and next week, so I don't want to overburden you with too much work. In these problems, you will see that there are these steps 1 and step 2. I'm just writing them down here just so that you have them if you wanted to refer back to them. But in the example and practice problems, these are the steps that we're going to be using for solving these sort of problems. All right, that is it for this video. Have a quality day.